All right, here's our second example of graphing rational functions. We're going to start just like we did in the past. We label the x-intercepts, the vertical asymptotes, the horizontal asymptote, and any holes that we might have. So we know from before that before we can get started, we're going to need to write this in factored form. So when we factor the denominator, we're going to get x minus 2 times x plus 1. And already, hopefully, you notice here that x plus 1 over x plus 1 is going to make a giant 1. And therefore, we're going to have a hole when x is negative 1. In order to find the height of that hole, we can just plug negative 1 into the part of the function that remains. So we'd have 1 over negative 1 minus 1, minus 2, sorry. And negative 1 minus 2 is negative 3. So we're going to have a hole at negative 1/3. Okay, great. So now we're going to look for x-intercepts, vertical asymptotes, and horizontal asymptote. So since this x plus 1 factor is part of the whole, we're actually not going to have any x-intercepts. The vertical asymptote will come from the x value that makes the denominator 0, in this case x equals 2. And for the horizontal asymptote, again, we're just going to look at where the larger degree is. You can consider that with the whole as part of the function or with the whole removed. Either way, you can see that the higher degree is going to be in the denominator. So as x goes off to infinity, the denominator is going to be getting larger and larger and larger, while the numerator will not. And we know that tiny over huge equals 0. Once we have all that figured out, we can start on our graph. Zoom in a little. Okay, just like before, the best thing to do to get started is to mark your asymptotes. So we have a horizontal asymptote when y equals 0. And a vertical asymptote when x equals 2. All right, and now all we need to do is figure out if our curves are kind of in which parts between our asymptotes that they go. We already know that we have a hole at negative 1, negative 1/3. It's going to be right there. So we know that this part of the curve is going to be below this asymptote and moving in like this. So the only thing we have left to check is this side. We can probably assume that it's going to be up here, but what we can do is we can plug in a value of x that is greater than 2 and see what happens. So if x were greater than 2, we would have let's pick a number. Again, it can be any number greater than 2. Let's say 5. 5 plus 1 over 5 minus 2 over 5 plus 1. And we can see that all of these values are going to be positive. So when we multiply and divide, the final answer will be positive. Therefore, we know that this section of the curve is going to be above the x-axis. Since it's positive, it's going to just go right here.